So we have 5 limits here, and we're asked to figure out which one of them is equal to 0. I'm just going to go through each limit individually. So we'll start with answer option A. We're looking at the limit as x goes to infinity of g of x, which is x squared, over f of x, which is 2x. Now, if we look at what happens when x goes to infinity, x squared is going to infinity, and 2x is also going to infinity. So when we have this infinity over infinity situation, this is an indeterminate form. So we can use L'Hopital's rule. We can differentiate the numerator and the denominator. So this is going to be equal to the limit as x goes to infinity. And on the top we have derivative of x squared is 2x. And on the bottom, derivative of 2x is 2. And the 2's cancel out, and we're left with the limit as x goes to infinity of x. And that limit does not exist, or it goes to infinity, whatever you want to call it. But the point is, it is not 0. So we know that the answer is not choice A. Now I'll erase this, and we'll do the choice B. So we're looking at the limit as x goes to infinity of g of x, which is x squared, over 2 to the x. And again, as x is going to infinity, x squared is going to infinity, and 2 to the x is going to infinity. So we have another infinity over infinity situation on which we can use L'Hopital's rule. So I will do d dx and d dx. And this is going to give me the limit as x goes to infinity. And the derivative of x squared is going to give me 2x. And the derivative of 2 to the x will give me 2 to the x, natural log of 2. And what do we have here? 2x, as x goes to infinity, and, well, natural log of 2 is like a constant. We don't even care about that. 2 to the x also goes to infinity. So we have another infinity over infinity situation, and we can use L'Hopital's rule again. But perhaps before I do that, natural log of 2 is a constant. I can bring that on the outside of the limit. So let me just do that. So we'll say that this is equal to 1 over natural log of 2 times this limit. And now I'll go ahead and differentiate the top and the bottom again. And bring it over here, so we know that this is equal to 1 over natural log of 2 times the limit as x goes to infinity of derivative of 2x is going to give me 2. And on the bottom, derivative of 2 to the x is again going to give me 2 to the x, natural log of 2. Well, 2 is just 2. And the x, the 2 to the x right here, as x goes to infinity, this is going to infinity. So basically, we have what is commonly known as small, namely 2, over big, namely infinity. And we know that small over big goes to 0. So we know that this limit goes to 0. So we know that B is the correct answer choice. But I am going to go over the rest of the answer choices too, for the sake of learning. So for answer choice C, we're looking at the limit as x goes to infinity of h of x, which is 2 to the x, over f of x, which is 2x. And as we've seen, 2 to the x is going to infinity as x goes to infinity, as is 2x. So infinity over infinity situation, we are going to do L'Hopital's rule. Differentiate. This is going to be equal to the limit as x goes to infinity of, on the top, derivative of 2 to the x is going to give me 2 to the x, natural log of 2. And on the bottom, derivative of 2x is going to give me 2. This time we have 2 to the x in the numerator. This goes to infinity as x goes to infinity. But on the bottom, 2 is always 2. So we have big over small, which goes to infinity. So we know that this limit goes to infinity. Now for choice D, we're looking at the limit as x goes to infinity of h of x, which is 2 to the x, over g of x, which is x squared. And this is going to infinity, and so is this as x goes to infinity. So we are going to do the L'Hopital's rule again. So I'll do a d dx and a d dx. And this will be the limit as x goes to infinity of, on the top, derivative of 2 to the x. Let me just write this a little neater and make sure it looks like 2 to the x. Derivative of 2 to the x is 2 to the x times the natural log of 2. And on the bottom, derivative of x squared is going to give me 2x. And on the top, 2 to the x, this is going to infinity. And so is 2x. So we still have infinity over infinity. We have to do L'Hopital's rule again. Let me get rid of this. So we know that this is equal to, so here we have the natural log of 2 in the numerator. I will pull that outside of the limit. This is going to be the natural log of 2 times the limit as x goes to infinity of derivative of 2 to the x. Remember, I already got rid of this factor, pulled it on the outside, so I just have to differentiate this. Derivative of 2 to the x is going to give me 2 to the x times natural log of 2 over derivative of 2x is going to give me 2. And here we have top goes to infinity, and the bottom goes to 2. So this limit also goes to infinity. And for the last one, I know I erased a little bit at the bottom, but we can still see that this is the limit as x goes to infinity of h of x, which is 2 to the x, over f of x times g of x. So f of x is 2x, g of x is x squared. So if I have 2x times x squared, that's going to give me 2x cubed. And as we can see, this goes to infinity, and this goes to infinity. So I have to use L'Hopital's rule. Whoops. So I'll write down d dx and d dx. And this will be equal to the limit as x goes to infinity. And on the top, derivative of 2 to the x is 2 to the x, natural log of 2. And on the bottom, derivative of 2x cubed is going to give me 6x squared. Now, as you can see, this still goes to infinity over infinity. So I have to do L'Hopital's rule again. I'm not going to go through the whole thing, but we can see that there's a little pattern here. So basically, I'm going to bring this to the front and then subtract 1. So I'm going to have an x to the first. And then when I differentiate this on top, I'm going to get the same thing. I'm just going to have to multiply by another factor of natural log of 2. So I'll have like a natural log squared of 2. Still a constant multiple, so it doesn't make much difference. Then I'm going to do it one more time on the bottom, and I'll have a derivative of 12x is just going to give me a 12, and then I'll have a natural log cubed of 2 on the top. So basically, I'm going to have 2 to the x times a constant on the top over a constant. And I don't have to worry about the constants. So this is going to give me the limit as x goes to infinity of 2 to the x times some constant over some constant. The top, 2 to the x times the constant, is going to go to infinity. And the bottom, the constant is going to go to that constant. So we conclude that this limit is going to go to infinity. So we've crossed off all the other answers, and we conclude that the answer is choice B.